Electrode and electrochemical cells. Electrochemical cells. A cell that has two half cells. Two half cells have been connected by a salt bridge. Simple half cells have a metal as electrode and solution a compound containing metal. Two half cells produce small voltage if connected into a circuit like become battery or cell. Why does voltage form? When connected, one half cell has more wanting to be oxidized and release electrons than another electrode. More electrons will build up on oxidized electrode than other electrode. Potential difference created between two electrodes. Oxidized side is negative. Size and reduced side is positive side. Potential difference is measured with high resistance voltmeter and given. Symbole. Why use high resistance voltmeter? Voltmeter is high resistance to stop current from flowing in circuit. So, measure maximum possible potential difference. Reactions will not be happening because very high resistance voltmeter stops current from flowing. Salt bridge. Salt bridge connects the circuit and allows free moving ions conduct charge. Salt bridge is made from filter paper soaked in salt solution, which is normally potassium nitrate. Salt unreactive with electrodes and electrode solutions. Potassium chloride. Can't be used on copper electrode because the chloride ions would react with copper to form copper complex. Wire not user because salt wire would create an electrode system with solution. What happens if current flows? When voltmeter is replaced with a bulb or it's short-circuited a current flow. Reactions will then happen separately at each electrode. Voltage will fall to 0 as reactants are used up. Positive electrode is reduction and negative electrode is oxidation. Practical setup. Electrical contact between the electrode and solution is improved in two ways. 1. Rubbing electrode with sandpaper to remove oxide later surface of electrode. 2. Wiping electrode with propanone to get rid of grease on surface of metals. Cell diagram. Used to represent electrochemical cells. Solid vertical line is difference in phases like electrode and electrolytes. Voltage produced is given. More positive half cell is on right side. Double line is salt bridge between two half cells. Follow our our so reduction, then oxidation, then oxidation, then reduction. Oxidation is really positive and reduction is the electrodes basically. Separate same state, different ions in cell diagram using commas. Systems without metals. No metal that can be an electrode, then use platinum electrode and put it in. Cell diagram. Platinum electrode gives conducting surface for electron transfer. Platinum electrode is used because it's unreactive/inert and conducts electricity. So, first look at half equation. If everything's aqueous, then you use platinum as the electrode, but if one thing's solid, then that's your electrode. If system has a lot of species in equation, then leave out water and H+ ions. In the cell diagram, measuring electrode potential of cell. If you can't measure potential of half electrode on its own, then measure potential difference between two electrodes. Measure this by connecting to another half cell of known potential, and potential difference between two half cells is measured. Give relative potential to each electrode by linking it to reference electrode, which is hydrogen electrode, which has potential 0 volts. The standard hydrogen electrode. Potential of all electrodes are measured compared to potential of standard hydrogen electrode. Standard hydrogen electrode is given potential of 0 volts. Hydrogen electrode equilibrium is hydrogen gas, which produces two H+ ions and 2 electrons. In cell diagram, platinum solid electrode with hydrogen gas with H+ ion. Aqueous. So, phase boundaries between gas and solid and aqueous and gas. Components of standard hydrogen electrode. Make electrode standard using hydrogen gas at 100 kilopascals, hydrogen ions at 1 mole per decimeters cubed at temperature of 298 Kelvin and platinum. Electrode. Equilibrium doesn't have conducting metal surface. A platinum wire is used, which is coated with platinum. Platinum black is used because it's porous and absorb hydrogen gas. Standard condition needed because position of redox equilibrium will change. With condition, increase in concentration of metal ion would move equilibrium to the metal side, so potential more positive. Standard hydrogen electrode is difficult to use, so different standard is used, which is easier to use. Other standards are calibrated against standard hydrogen electrode. This is called secondary standard, like electrode that has been calibrated against primary standard. Standard electrode potential. When electrode system is connected to hydrogen electrode system and standard conditions apply, potential difference measured is called standard electrode potential. Standard condition is all ion solution at 1 mole per decimeter cubed. Temperature of 298 K. Gases at 100 kilopascals pressure and no current flow. More oxidized on left. Calculating EMF of cells. Use standard electrode potential to calculate Ecell values. You can use one of two equations. 1. Ecell equals E right-hand side, E left-hand side. 2. Ecell uguale E reduced E oxidized. Using electrode potentials. Use them to find direction of spontaneous change in redox reactions. More negative half cell is oxidized, so electrons given off and transferred to positive electrode, and more positive half cell is reduced, so electrons gained at the electrode. So, to work out Ecell, use the second equation provided above. Spontaneous changes have a positive Ecell value. Using series of standard electrode potentials. More positive means species really wants to be reduced, so it wants to be an oxidizing agent. On left side of equation. More negative means species really wants to be oxidized, so it wants to be a reducing agent. On right side of equation. Top right is strong reducing agent, so more negative. Bottom left is strong oxidizing agent, so more positive. When answering questions, make sure you say what's been reduced and what's been oxidized. Also say, what from like water to oxygen. Be clear. Give values, redox equation, conventional representation, and work out Ecell. Say Meyer positive is reduced and most negative is oxidized. Effective conditions on cell voltage, Ecell. Figure this out using Le Chatelier's principle. Ecell is how far from equilibrium the cell reaction is. More positive Ecell means reaction more likely to happen. If current flows, then cell reaction happens, and Ecell goes to 0 as reaction happens because reactants are being used up. Effective concentration on Ecell. Increasing concentration of reactants means Ecell increases. So decreasing concentration of reactants means Ecell decreases. Can manipulate this to make Ecell increase by increasing concentration of ion in more positive electrode and decreasing concentration of ion in more negative electrode. Effective temperature on Ecell. Most cells exothermic in spontaneous direction, so using Le Chatelier's 4. Temperature increase means decrease in Ecell because equilibrium shifts backwards. Positive Ecell means reaction happens, but there's still a possibility of reaction not happen, or it happens so slowly it's practically not happening. Cells. Used commercially for electrical energy. Cells are non-rechargeable. Rechargeable or fuel cells. Non-rechargeable cell example is a dry cell, and cells are non-rechargeable because reactions that happen in them can't be reversed. Another example is a lithium cell, which is non-rechargeable. Rechargeable cell example is lead acid cell, and for this, the forward reaction happens giving out charge, and changing conditions can cause reverse reaction to happen, and these reactions only happen if the product stays on the cell and doesn't disperse. Lithium-ion cells used to power phones. The half equations are lithium ions reacting with cobalt oxide and an electron to form lithium cobalt oxide. Positive. The other reaction is lithium ions gain an electron forming lithium. Reverse reaction for recharge. Reagents absorbed on a powdered graphite that acts as a support, which allows ions to react when there's no solvent, and water's not good because it would react with lithium metals. Fuel cells. Uses energy from reaction of fuel with oxygen to create voltage. Hydrogen fuel cell is when 2 electrons and 2 waters make hydrogens and 2 H-. At the other electrode, 4 electrons and 2 waters and oxygen, which forms 2 hydroxide ions. Fuel cells have constant voltage over time because they're given oxygen and hydrogen constantly, so have a contact concentration of reactants different from normal cells where voltage drops as reactant concentration drops. Can't use standard conditions because then you can't produce enough products, so we use higher temperatures to combat this, but this is exothermic. So according to Le Chatelier's, the Ecell value will be less. So use high pressure. Co-combat this. Advantages of fuel cells over diesel is that they're more efficient and less pollution and less carbon dioxide is produced, and pure hydrogen emits only water, but hydrogen-rich fuel make only small amount of air pollutants and carbon dioxide. Limitations is it's expensive, hard to store and transport hydrogen, limited lifetime and high production cost, and use toxic chemicals in production. Hydrogen obtained by electrolysis of water, but this is expensive, and to be green it needs to be made of renewable resources. Hydrogen stored as liquid under pressure, absorbed on solid material. Ethanol fuel cells. Better than hydrogen fuel cells because ethanol made from renewable resources in carbon-neutral way. Raw material to make ethanol are abundant. Ethanol is less explosive and easy to store than hydrogen. New petrol stations are not needed because ethanol a liquid fuel.